بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم المرسلين نبينا محمد وعلى آله وصحبه أجمعين. We will continue solving some more exercises about section 7.8 improper integrals. So here question 32, integral from e to infinity. So this is an infinite limit. We write at limit when t goes to infinity. We replace infinity by t. So it would be integral from e to t 1 over x ln x to the power 2 dx. Well, if you take u equals ln x, then du would be 1 over x dx, and the integral would be integral of 1 over x dx would be du, and ln x square would be u square, so the integral would be negative 1 over u. If you take now, if you write it negative 1 over ln x and take it from e to t, then you will get this definite integral. So we write it here. We have negative 1 over ln t minus negative 1 over ln e, and ln e is just 1. Now if I replace t by infinity, ln infinity is infinity, negative 1 over infinity is 0, so I'll have minus minus plus 1, so the answer would be 1, and the integral is convergent. Now here, this function is not continuous at negative 2 because negative 2 makes the denominator 0. So this is infinite discontinuity. So I write it limit when t approaches negative 2, and the interval is, this is the interval, so I approach negative 2 from the right, and I replace negative 2 by t. So this is the second type of improper integrals. Well, let me write it. X plus 2 to the power 1 over 4. Then the integral is x plus 2 to the power 1 over 4 plus 1, which is 5 over 4 over 5 over 4, or times 4 over 5 from t to 14. So this would be limit when t approaches negative 2 from the right of, now if I replace x by 14, I'll have 14 plus 2, which is 16, and if I raise 16 to the power 5 over 4, I will get 32 minus 4 over 5, and I replace x now by t, so t times t plus 2. Now if I replace t by negative 2, I will have here negative 2 plus 2, this would be 0, and the answer would be 4 over 5 times 32, and that's 128 over 5, or just 25.6. So the integral is convergent. This function is not defined at 0, so it's not continuous at 0. So I have to write the integral from negative 2 to 0 plus from 0 to 3. Let me start by evaluating the first integral. Let me call this I. So I would be x to the power negative 3 over negative 3 from negative 2 to 0. course, I cannot do it like this because when I replace x by 0, I will have not defined. So you cannot do it like this. We have to write it as a limit. So limit, because the function is not continuous at 0. When x approaches, not x, t, when t approaches 0, and we write it from -2 to t. And we will approach the 0 from the left because the function is -2 to 0 of x to the power -4 dx. And this integral is x to the power -3 over -3, but now from -2 to t, not to 0. So I will have 1 or -1 over 3t cube, then minus, so it would be plus 1 over 3 times -2 to the power 3, which is -8. Now replacing t with 0 will lead to infinity. And if I want to know whether it's positive infinity or negative infinity, I can replace t by a number to the left of 0, -0.1, for example. So this would be positive. So the answer would be positive infinity, and the integral is divergent. I found only I is divergent, so that's enough to say that integral from -2 to 3, 1 over x to the power 4 dx is divergent. Remember, we said that integral 1 over x to the power 4 from 1 to infinity is convergent, but from -2 to 3, it is divergent. Well, this function is not continuous at 1 because 1 minus 1 will be 0, will make the denominator 0. So I have to write it from 0 to 1 plus from 1 to 9. Now let us find the first integral, I. It is the limit when t approaches 1 from the left of integral from 0 to t x minus 1 to the power -1 over 3 dx. Well, this integral x is x to the minus 1 to the power -1 over 3 plus 1 over 2 over 3 or times 3 over 2 from 0 to t. So it would be t minus 1 to the power 2 over 3 and 0 minus 1 is -1 to the power 2 over 3, it is 1. So that's just what we got. And when I replace t with 1, 1 minus 1 is 0. So the answer 0 times anything is 0 minus 3 over 2. So the first integral is convergent and it's equal to -3 over 2. So let us find the second integral. The second integral is the limit when t approaches 1 now from the right of integral from t to 9. And let us write it the same. X minus 1 to the power negative 1 over 3 dx. So now I have from 9 to t. I will immediately replace here because it is the same integral, but replace first x by 9. So I have 3 over 2, 9 minus 1, that's 8. That's 8 to the power 2 over 3, which is 4, and minus 3 over 2 t minus 1, replacing x by t to the power 2 over 3. And now if I replace t by 1, I will get 12 over 2, which is 6. So this is the second integral and this is the first integral. Now the final answer would be, if I call this the third integral, the final answer would be 6 minus 3 over 2, and that's just 4.5. And the integral is convergent. Here, this function is not continuous at 2. So let us write it from 0 to 2 plus from 2 to 5 dw. And let us start by finding this integral. So its limit when t approaches 2 from the left of this function from 0 to t, w over w minus 2 dw. And here we need to use long division to divide w by w minus 2. And I can write it as integral of w over w minus 2. I can write it as integral of 1 plus 2 over w minus 2. So the answer is integral of 1 is w plus 2 ln w minus 2 from 0 to t. And now this would be replacing w with t minus, if I put w0 here, it would be 0. Of course, this is absolute value. And if I put here 0, it would be ln 2. So plus, there is a minus, of course, minus ln 2. Minus 2 ln 2. If I put w 0. If I replace t by 2, notice here I have 2 minus 2, that's 0. And ln 0 is negative infinity, ln 0 plus. So everything here would go to negative infinity, and this integral is divergent. So the original integral is divergent. So if the two integrals are convergent, you add them and you find you say that the original integral is convergent, but if one of them is divergent, then immediately the original integral would be divergent. Well, here, this function, I need to factor the denominator. So it's x minus 2 times x plus 1 And now this function is not continuous at 2 and at -1, but only 2 lies in this interval between 0 and 4. So I write it from 0 to 2 plus from 2 to 4. And let me evaluate this integral 1 over x minus 2. I will write it as a over x minus 2 plus b over x minus 1. This would be equal to 1 over x minus 2 using partial fraction. So if I replace x by 2, I will have 1 over 3, that's a. And if I replace x by 1, this should be positive 1. So by -1, it would be -1 over 3. So I can write it as integral of 1 over 3, 1 over x minus 2, minus 1 over 3, 1x plus 1 dx. So let us evaluate this integral first, I. It is the limit when t approaches 2 from the left of this integral, which is equal to this integral 1 over 3 ln x minus 2 minus 1 over 3 ln x plus 1 from 0 to 2. And I will have 1 over 3 ln 2 minus from 0 to t. So ln t minus 2 minus 1 over 3 ln t plus 1, then minus. If I replace now x by 0, I will have 1 over 3 ln 2. And here minus times minus will be plus 1 over 3 ln 1, but ln 1 is 0, so there is no need to write it. Now replacing t by 2, I will have ln 0 here. And ln 0 is -infinity. So notice that the others are numbers. So the answer would be -infinity. The integral is divergent. And then the original integral is also divergent. The last question is not defined. I have a problem at 0 because ln is not defined at 0. So I just write that limit t approaches 0 from the right, from t to 1, r ln r dr. And I can solve this integral by integration by parts. So r, derivative 1, 0, ln r. No, I take, no, integration by parts, but u is ln r, not r. And du would be 1 over r dr. And dv is r dr. And v is r square over 2. So I will have uv minus integral v du, which is r over 2. So the integral would be r squared over 2 ln r minus half r squared over 2. That's this integral. And now I take it from t to 1. So it would be equal to limit t approaches 0 from the right. Replace r by 1. Ln 1 is 0. So I have negative r is 1. I have negative 1 over 4. Then replace r by t. So I'll have t squared over 2 ln t minus half or minus 1 over 4 t squared. If t is 0, this would be 0. But here, I have problem here because this would be ln 0, which is negative infinity. With this negative, I can make it infinity, and 0, 0 times infinity. So I need to use L'Hopital's rule to find the limit of negative t squared over 2 times ln t when t approaches 0 from the right. It gives me 0 times infinity, so I need to take t squared down. Negative 1 over 2, there is no problem with it. I have ln t here and t to the power negative 2 here. And now 0 to the power negative 2 is infinity, infinity over infinity, so I can use L'Hopital's rule. Derivative of ln t is 1 over t, and derivative of t to the power negative 2 is negative 2 t to the power negative 3, or over t to the power 3. Now simplifying this is 1 over t divided by negative 2 over t cube. So it's 1 over t multiplied by t cube over negative 2. So it would be t squared over negative 2. And now when I take t0, it is 0. So this limit is also 0. And the answer is negative 1 over 4. And the integral is convergent. That's the end of the exercises. Have a nice time and study hard.